Match the equation with one of the accompanying graphs and give the equation for the horizontal vertical asymptotes.
Okay, so we just have to have a quick review of horizontal asymptote and vertical asymptote. The horizontal asymptote is the y value we get if the limit as x approaches positive infinity of f of x equals L, or the limit as x approaches negative infinity of f of x equals L, then y equals L is a horizontal asymptote. Okay? And physically, what we're saying is that if in the long run it's approaching L, we call it a horizontal asymptote. You know, this isn't quite right. Anyone know why it's not quite right? If this thing came up and went back and forth like that, it wouldn't be considered a horizontal asymptote. So I'd have to add some stuff. I'd have to say that and is staying on one side of the line. You follow? If it crosses the line repeatedly, the limit could be L, but it would not be considered an asymptote. So if it stays on one side of the line and the limit is L, then it's a horizontal asymptote. The vertical asymptote is when we have x equals c, such that the limit as x approaches c from the left of f of x is either positive or negative infinity, or the limit as x approaches c from the right of f of x is either positive or negative infinity. Now, the way we get horizontal asymptotes for rational functions is we look at degree of the top, degree of the bottom. And if the degrees are the same, then we take the ratio of the coefficients highest degree terms. That value is the L. If the degree of the bottom is bigger, then y equals 0. The x-axis will be horizontal asymptote. You have vertical asymptotes for rational functions. We look for factors in the bottom that are not in top. Any x value that makes the bottom 0 but not the top is going to lead to a vertical asymptote. So we're looking at number 29, Michael, and you look at part A. And just read to me A.
Y equals x squared over x squared minus x minus 2.
Now the bottom factors into x minus 2, x plus 1. The top, x times x. So this tells us, since the degree of the top is 2, the degree of the bottom is 2, 1 over 1, y equals 1 is going to be the horizontal asymptote. The fact that these factors in the bottom are not on top, we know that x is 2, x is negative 1 are vertical asymptotes. Is that reviewing? And so which graph is it that has a horizontal asymptote at y is 1 and vertical asymptotes at x is 2 and x is negative 1?
2.
Roman numeral 2. Okay? Who's up next?
Kevin.
Calvin, what's part B?
Y equals x minus 1 over x squared minus x minus 6.
Back to the bottom. Can you do it real fast?
And the
Anybody?
x minus,
You got it.
x minus 3, x plus 3.
Awesome. So the degree of the bottom is bigger, so there's a horizontal asymptote. Y is no. That's the vertical asymptote. X is 3. X is negative 2. Horizontal asymptote, since the degree of the bottom is bigger, as x goes to infinity, the bottom is way big. You have a number divided by something way big, you get 0. So y is 0. Which graph is it where the x-axis is an asymptote and x is 3 and x is negative 2?
The first one.
Everyone agree? There are questions I'm doing the third or fourth ones, C or D. Do I need to do them? And speak up if we need to do them. All right, let's go to 33. Michael, just let us know who's
It was Helen.
Helen, 33.
In each part, find an equation for the graph that has the form y equals y squared of the a times dx minus c.
And I prefer y equals k plus a sine 2 pi over the period x minus 5. And so even though the authors asked you to write it this way, if you write it that way, I can't take off. It's what the authors asked, but I prefer that you write it this way. Okay? And so there's how many parts are there? 3. Okay, you guys need to be looking in your book, number 33. What's the midline of 33? What's the average y value? What's the line where it goes the same amount above and below from that? The x-axis, so k is 0. So the y value is 0, k is 0, midline is 0. How far does it go up? How far does it go down from the x-axis? What's the amplitude? What's the period of this curve? What's from top to top? 2 pi. And what's the phase shift? How much is it shifted over? If it's a sine curve, we look to where it's in the middle, heading up. Is it right at the y-axis, or is it shifted? Phase shift for A. I looked on Rafa's for
Pi?
looks like that it's over there 3/4 of the way, right? 3 pi over 2? Do you see where I'm getting 3 pi over 2?
No.
Am I looking at the wrong curve? Okay. This is at 2 pi. This is at pi. This is at 0. This is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So it's a 3 pi over 2 where it's in the middle heading up. So the phase shift is 3 pi over 2. Someone else would work backwards and say the phase shift is a negative pi over 2. There's an infinite number of legitimate phase shifts. We usually take the one closest to 0 or the first positive one. So we'll take the first positive one. And so final answer y is 0 plus 1 sine of 2 pi over 2 pi x minus 3 pi over 2. That's beautiful. You do not need to simplify it in my view, because we're looking at it knowing the period is 2 pi, knowing the phase shift, knowing the amplitude. Just read it right off. Let's do one more of those. Who's up?
It was Helen. Or Tyree, sorry.
Tyree. B, C, or D? Which one do you think is most interesting?
Let's do
B. What's the A value, the midline, the average Y? 3. You guys got to speak up. I'm not even looking at the graph. I'm counting on your 40 eyes out there to 26, 20, 24 eyes. Let me know. So what's the amplitude? What's the period? What's the phase shift? 0. Any disagreement? So we read across, the answer would be y equals 3 plus 3 sine of 2 pi over 9 pi x minus 0. I like that answer. I know that's not what the author would have. Okay? Obviously, they're simplifying this term into b, expanding it through if necessary. It would have been on this one, not on b. Anyone have an issue with C or D? Can you go for it and then worry it? Okay, we're not going to do C or D. Let's go to 35.
Always.
Eloise, 35.
Find the amplitude in the period and describe the last 2 periods of the graph by hand. If you have a graphing utility, use it to check the word.
Okay, we're going the other direction. We have a sinusoid again, we're going the other direction. What's the equations?
The y equals 3 sine of 4x.
Is this part A?
Yes.
Okay. I'm going to rewrite it out. Y equals 0 plus 3 sine of 2 pi over something x minus 0. Now I know that 4 is 2 pi over the period. So that yields the period is 2 pi over 4, which is pi over 2. So I'm going to put pi over 2 right here. Notice 2 pi divided by pi over 2 is the same as 4. Okay? So that means they gave me an equation. So it's similar to this other one, but I'm not going to actually graph it. We're going to graph it this way. One little trick is don't put any tick marks down so you know exactly what you're doing. Middle value is 0, so I put a dotted line there. Y is 0, it's the middle value. The amplitude is 3, so we come up 3, then we come down 3. I'm actually going to put dotted lines across there. That's going to be the top and bottom of the sinusoid. Now the phase shift is 0. It's a sine curve, so it's starting in the middle, heading up, and the period is pi over 2. So here's pi over 2. It's going to be a full deal. Here's the pi. It's going to be a second full deal. And then we like to break it into fourths. Okay? So we come in the middle, which of course is pi over 4. In the middle of the middle, these are pi over 8. So this is 3 pi over 4. And in the middle, it's there, a quarter of the way to the top, 3/4 of the way to at the bottom. And it's going to repeat. A quarter of the way top, middle, 3/4 at the bottom, and back. They wanted at least 2 full periods. I think we've done it. You could type it into the graphing calculator. I think you'd find it matching up very well. Do I need to do B, C, or D? Anybody worried about them? That's fine. So you're getting the reminders about this, and that's what the goal is. And we're gonna have more time for you guys to work on homework this way. So, yes.
Can you do,
Sure. Let's do C. 35C. Who's up next, Michael?
Alois again.
Alois, read 35C.
Y equals 2 plus the cosine of x over 2.
Cosine of x over 2. Okay, now what we're going to realize is that a sine curve looks like that normally. A cosine curve starts at top, looks like that. If they actually had a negative sine curve, we'd have to flip it. If they had a negative cosine curve, we would flip it as well. So we understand these basic curves, take the opposite of them, they flip across the, really, y is this, so we're multiplying by -1, so it flips over the x-axis. This is a positive cosine curve. Alois, the k is
2.
The amplitude is
0.
no,
It's 1.
it's 1. There's a 1 there. It's not 0 of those. It's 1 of those. We know that 1 over 2 is 2 pi over the period. This number 1/2 is 2 pi over the period. So what's that make the period equal to? Cross multiply. The period is
2 pi over 1.
cross multiply 1 times period, 2 times 2 pi, 4 pi. You see it? And what's the phase shift?
Not 0.
There's no phase shift. So to graph it, we go middle is 2. The amplitude is 1, so we go 1 above it, 1 below it. There's no phase shift. The period is 4 pi. So once it goes 4 pi, it's done a complete cycle. And so double that, 8 pi, it's done another complete cycle. It's a cosine curve, so halfway through it's all the way to the bottom. So 2 pi is all the way to the bottom. That's going to happen at 6 pi as well. And at pi, it's in the middle, bottom, middle 3 pi top, middle 5 pi bottom, middle 7 pi top. There's 2 full periods. And we should label the y, label the x. I think that's pretty decent. Okay? Alright, number 8 was a homework problem. So, if you had 8 done before I do it in class, give yourself a +1 on your homework, okay? But if not, it's just the task and one that I usually have to help a lot of people out. I might not do it the entire way, but let's see. Michael?
It's me.
Okay, read number 8.
Find all lines through 6, -1, push the product of x minus x 3.
They go through 6, -1, and the product of x and y intercepts is 3. Okay? We want all the lines to do it. So we're going to graph it. -1. And somehow, if you take the x-intercept times the y-intercept, it makes 3. The easiest way to do this is to go with x over a plus y over b is 1. It's called double intercept form. Now there's many ways to do this problem, but I think this is the easiest. This is a pretty difficult problem. If we go with x over a plus y over b is 1, we sort of have two things we have to find to get the equation of the line. Because at the end, the equation has x and y in it. So we really have two things we want to find. So we need another piece of information that goes with a and b, but they gave it to us right there. They told us that a times b is 3. Okay? They also told us it goes through the line 6, negative 1. So I can put 6, I can put negative 1, and instead of b, I'm going to put 3 over a. And this has to be true. Because we know that it's a line. We know it has two intercepts. The product is 3. It can't be one of them. It's got two intercepts. Okay? So this equation is going to work. We know that the 0.6 negative 1 works. And we know the product is 3. So b is going to be 3 over a. So you might, since it's just homework, you might just solve this on the calculator for a. It'll give you both answers. On the calculator. But we'll do it by hand. I'm going to write this as 6 over a plus negative a over 3 is 1. Instead of divide by the fraction, multiply by the reciprocal. Michael, what do I multiply by to show out the fractions here?
A times 3.
Awesome. So multiply by a times 3 or 3 times a, and it gets us
18 plus a negative a squared. And equals 1. Equals 3 after that.
This is quadratic. Move the a squared over. We have a squared plus 3a minus 18. That factors into what?
Minus 6.
A squared plus 3a minus 18 is 0. Factors into what?
Minus 6. Or plus 6, not 3.
Plus 6 minus 3, which means that a is negative 6 or a is 3. A is negative 6. Physically saying that the x-intercept is back here. If a is negative 6, then it connects up there. This is 1. Halfway through it's going to be a half, right? Negative 1 half. Notice what negative 6 times negative 1 half is. It's 3. Look, b was 3 over a, so b is negative, it's 3 over negative 6, so it's negative 1 half. But if a is 3, 1, 2, 3, let's do it down this way, 1, 2, 3, this, so one of the lines is this line, the other line is this. This is back 3 up 1, back 3 up 1. Look, b is 3 over 3, which is 1. Final answer, I'm just doing this problem. We get x over negative 6 plus y over negative 1 half equals 1, or x over 3 plus y over 1 equals 1. There's the solution. Both of those lines work. We can see it physically that they work. There's no others that work. We solved it with quadratic. Pretty hard. So if you had that done before, you get some bonus. If not, I didn't succeed. Quite hard. All right, moving on into 0.4 to give you a little bit of head start. Because over the long weekend, 6 days from 7 days from now, we don't meet again until a week from now. Ideally next Tuesday, you can get your 0.4 done by the end of the day. We'll see how that goes. I'll be reasonable. Who is it?
Maddie.
Okay, Maddie, number 5, 0.4, number 5. We're moving into inverse functions.
In each part, determine whether the function f defined by the table is 1-to-1.
1-to-1 function. What's the idea there? For all x, there exists a unique y, and for all y, there exists a unique x. You ever seen that notation? I think I've taught this to you now too. For all x, this means there exists a unique y. So for every x, there's only one y, and for every y, there's only one x. It means, i.e., It passes horizontal line, I'm going to say it the other way. It passes the vertical line test and a horizontal line test. It's 1 to 1. 1 to 1. Every X has one and Y, vice versa. It's 1 to 1. So a lot of times if you have a graph, you look, this has the vertical line test and the horizontal line test. Okay? So part A,
1 to 1.
yes. You guys all looking at the graph? Any issues? Passes both tests. Part B,
It's not 1 to 1.
not. In the instructions, you just to say yes or no, right? Sometimes they ask us to limit the domain so it is 1 to 1, but they didn't do that here. Part C,
Very important.
good job. Any questions on 5? Follow-up questions? We'll just go to number 8. Spencer, 8.
Explain why the function f graph in the accompanying figure has no inverse function.
Okay, now one thing we learned is that if it's not 1 to 1, it doesn't have an inverse. Because the idea for an inverse is, you have a y value, you know exactly what x value came from. But if an x can have 2 different y's, or a y can have 2 different x's, we can't do it. Alright? It's actually the second thing. If x had a different y, it wouldn't be a function to begin with. Okay? But if a y had 2 different x's, no good. So number 8, why is it? The graph looks like this, right? Negative 3 to 3. And so what's the reason that it doesn't have an inverse? It passes the vertical line test. So it has a function. That's not a reason. Why does it not have an inverse? It's got to pass both. No inverse since it fails the horizontal line test. This y value had 3 different x's that went with it. You don't know which one to go back to. You go backwards, you don't know where. You give me an x, it gives me one particular y. But when we have a y, we don't know which x that came from, necessarily. Okay? There's more to that, I think.
Because subdivide the domain to the adjacent intervals on each of which the function has.
Okay, I want to have 3 subintervals where it does have an inverse. In other words, we need 3 subintervals where it does pass the horizontal line test, the vertical line test. So where do I break it up? Basically, just use some words so I know where to put it. The maximum spot, break it up there, and I heard him say the minimum spot, break it up there. From the graph, what is this x value is negative 3, this x value is 3. What are these 2 x values? From the graph, can you tell?
They're negative 1 and the other negative 2.
So, negative 3 to negative 1, negative 1 to 2, 2 to 3, those are the intervals. Each of those subintervals would have an inverse function. This is what we do with the sine curve. The sine curve does not have an inverse. But you guys have all seen this function. We call it the inverse sine of x. So how are we doing that? Well, we're breaking it up, and we're only taking the portion from negative pi over 2 to pi over 2. It's the only portion we take. And so our inverse leads us back to that domain, negative pi over 2 to pi over 2. We do the same for cosine and tangent, all the short portions. Is there more to 8? I don't think so, right? Okay, number 15. I read 15.
Find the formula. Find the formula of
F minus 1 of x, or the inverse f, the inverse function of f, the inverse of f of x.
f of x is
Okay.
the top one is 5 times 1 of x. 1 of x is less than 2. And then 1 over x.
Okay, now I'm going to take a couple minutes on this. And it's going to be lots of review, and this is a problem that I always put on the test. And it bothers students every year. There's some difficulty to this. I think you should be able to get it, but it's tough. You have to really know what you're doing. It's a great pre-cal problem. I just want to remind you a little bit. If we had y was 5 halves minus x, and I asked for the inverse, I would draw a line. This is what I touched on here too. Draw a line, swap the x's and y's, and solve for the new y. So y is x minus, y is 5 halves minus x. Very interesting. This is a curve whose inverse was the same as the original. Because this particular curve is symmetric about the line y equals x. And the inverse is the reflection across the line y equals x, and you get itself. If we take the y is 1 over x, draw a line, swap it, cross multiply, get the y alone. This also has the same inverse function as the original. Okay? So, I'm going to do something wrong here. I want to know if anyone can tell me what's wrong. So the inverse is, well, the inverse of 5 halves minus x is 5 halves minus x. That clearly isn't wrong. Okay? X is less than 2. And the inverse of 1 over x is 1 over x. If x is greater than equal to 2. That's wrong. You know what the mistake is. I told you this isn't wrong. This isn't wrong. So what's the mistake got to be? These restrictions. These are wrong. I said 1 over x. That was wrong too. It's supposed to be 1 over x. So 1 over x isn't wrong. The restrictions are wrong. Now let's graph it and see what's going on. So I'm going to graph it. And I'm going to graph it in red here. Let's see if I can graph it reasonably well. 5 halves minus x is a line, the y-intercept is 2.5, slope is -1. So it actually goes through these points, and if I plug in 1, if I plug in 2, I get 1/2. So the reason I'm doing that is, so I'm doing the original function in red, and 1 over x, you guys know that curve is this. I'm not even bothering with this half. I'm really not even bothering with this, but we take that. You follow? I took the line when x was less than 2, and I took this 1 over x curve when x is greater than equal to 2. So if we're going to reflect that across the line y equals x, this reflected across, this point is 2 1/2, 1/2 comma 2 ends up being the key spot, and we get this blue line, the inverse is in blue, the inverse is in blue. And when I reflect this across, it ends up being that. The key spot at the beginning was x2, y 1/2. Inverses are when you swap the x's and y's. It turned around at x comma 2, y comma 1/2 at the beginning. So where's it turning around on the inverse? 1/2 comma 2. But we're defining it in terms of x. So I need to say it's 5 halves minus x if x is greater than 1/2. And it's 1 over x if x is less or equal to 1/2. So when I give this problem, most students are able to find the inverse for the one function. It rarely comes out as a self. And they get this correct. They do the inverse of the second function correctly, and they get this correct. But they have a lot of trouble with two things. First, finding the number that belongs here. Some of them catch on, and once you get the key spot at the beginning, it's just a flip of that, swap the x and y, it's the key spot at the end. But then you also have to be very careful about these signs, okay? You have to be very careful about the signs. There's not a formula for doing that. It's quite challenging, okay? Yeah. On the test, no. I'll give you one like that on the test, no calculator. You have to be able to do it. So you're gonna, it's gonna be based on curves that I believe you're comfortable with and should be able to graph by hand pretty quickly. So you'll see the practice test, and you have one on homework similar to that as well. Number 19. Just want to real quickly look at 19 and see if we need to deal with that. Okay, yeah, let's just do 19 real fast. I'll do it right over here. Spencer, 19.
Find a formula for f of negative 1 of x and state the domain of the function f of negative 1. And
Okay.
f of x equals negative the square root of 3 minus 2x.
Okay, by the way, a function and its inverse, you swap the domain and you swap the range. I think you learned that. Okay, you swap the domain and range between a function and its inverse. So the domain of f, we need 3 minus 2x to be greater than or equal to 0. So negative 2x is greater than or equal to negative 3. So x is less than or equal to 3 halves. So I'm just going to go with negative infinity to 3 halves. In the range of f, does anyone know what the range is? It's a little bit tricky. Anyone? What's the range of this function going to be?
Less than 3 halves.
No, the domain, the x had to be less than or equal to 3 halves. The range of f, not the inverse. Yes, it's going to be less than or equal to 0. Because this is the principal square root, which is 0 or positive. We take the opposite of it. So, negative infinity to 0. So I already have the domain of f minus 1 and the range of f minus 1 without doing anything. Because the domain is going to be negative infinity to 0. And the range then is going to be negative infinity to 3 halves. Because the domain and the range swap between the function and its inverse. Now, I'm going to write this as y is the opposite of 3 minus 2x. So, we draw the line, and what do I write next? This is Spencer's, right? What do I write next?
X equals negative square root of 3 minus 2y.
Next line? Multiply by negative 1.
And then square both sides.
Square both sides. Then what?
Subtract the 3.
So x squared minus 3 is negative 2y.
Divide by negative 2.
Divide by negative 2. And so we have the inverse is x squared minus 3 divided by negative 2. And especially when we throw this domain in properly, we're good. And the domain and range is just swapping from the original function. So that's good review. Done for the day. You have a decent amount of time to work. I'll try to help you.